Hit the red light. There it is. Hey, 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 everybody. It is Astronomy Daily Live for the 10th of September. Is that right? The 10th of September? I'm going to look at my... Yeah, for the 10th of September, 2018. It is 2 hours UTC on the 10th of September 2018. So welcome. Come on in. Come on in, everybody. Join the circle of friends, the virtual lounge where we sit around, we gather from all parts of the world. It's really, really amazing. I'm getting, for still, the relatively few number of subscribers, few number of views and all that. It's nice to see a pretty good variety, right? United States is represented, of course, but Iceland has been in here, Afghanistan has been in here, Australia, England. I'm trying to remember if there was anybody else. But, that's not too bad. It's not too bad for a little channel that's, obviously trying to cover a big subject, big subject, but sort of in a way that might be different from other astronomical podcasts in that this is just a fun gathering of friends, very, very casual, but I don't want to call it serious, but we're not really messing around here. We're not it's fun, but it's serious at the same time. And I think that is really, really cool. And, to keep it fun and to just share the passion is what this live stream is doing, and always trying to get better at that as well. So I'm going to look at the chat, and at the same time, I'm going to say hey there to Bobby on the panel again. Hey there, Bobby. What's up?
Hey, what's up, everyone? And Arthur Water was asking, what happened to our intro? He was a bright person, very good at math.
I think our intro, if I recall correctly, right, looking in the chat, I think he's actually sort of at his day job when this live stream goes. So maybe our intro picks it up later, or is going to come on when they can come on, and that's one of the cool things, right, about having this daily sort of pretty casual live stream is that please don't feel as though you have to come here every single day, right? I mean, when you do, I'm absolutely thrilled, right? I mean, it's great. It's like seeing friends, every day, and that is very, very cool, right? But don't think that you have to, right? I mean, take a break. I don't really even feel an obligation to, but I'm having so much fun that it doesn't feel, like an obligation. This is the kind of thing that I have done my entire life, and it's not hard at all. And that's actually one of the reasons why I decided to start doing this live stream, was because...
What's up, Uncle Bill?
Hey there, Uncle Bill.
Our intro is still quite active with the Whiskey Sierra Hotel cruise stuff. They cost us about the scheduling conflict.
Yeah, I think that's all it is. So yeah, our intro is more than welcome back anytime, as long as the subject matter is basic astronomical stuff. Yeah, once in a while it's fun, to get off on tangents and stuff, and that's okay. that's all right, because this is a gathering of friends. Primarily, this is a gathering of friends, right? So,
Otawada, did you ever get the alignment problem on the mini telescope figure out or no?
actually, yeah, I need to get out back under a dark sky to work that out. So as soon as I do, I will, and hopefully that'll actually be happening this week. It's I think our monsoons are sort of starting to sort of dial down a little bit, or at least there's a little bit of a lull. But it's that time of year that the monsoons start to slow down and we start to fall, right? It's
Now let's see. What do I want to ask? And is Uncle Bill still having bandwidth issues?
oh, I don't know. I don't know. Uncle Bill will have to answer that one. So I've got the HOH again today. Hydrogen hydroxide. Very awesome stuff. I highly recommend it. Highly. Cheers. And it always.
What's up, Crooked Ninja?
Hey there, Crooked Ninja. And it always blows my mind, right, to think about the fact that there's about a mole of HOH here, right? About a mole, and 1 mole of anything is about is it 6? I think it's like 6 times 10 to the 23rd molecules, right? This
Now, just out of curiosity, you find this Astronomy daily live show much better than a stupid football game?
What's that?
Does anybody here find Astronomy daily live better than a stupid football game?
Well, yeah, I think that's a matter of opinion. So, and that is one of the great things about this live stream, right? Is that because it's daily, right? If there is something else that you want to see, right? If there's a football game or whatever, right? I mean, any kind of astronomical event, right, that is taking place at your location during this time, I say, go do that, right? Because this live stream will be here tomorrow and the next day and the next day. So
Uncle Bill Doran says ISP bandwidth nomio. The bandwidth between my ears is overtaxed.
Yeah. That sounds.
And I think I can agree with her. It depends on who is playing in the stupid football game.
Yeah. Don't
Like I said, college is okay. NFL probably not my cup of tea.
Okay. Well, like I said, this is this live stream, welcomes you whenever you decide to come on in. Everyone is, at least mostly everyone, is extremely welcome, and yeah, just really, really grateful for everyone showing up and getting into some, at least a little bit of discussion about various astronomical topics.
Now, let's say if your team loses and you're with some friends, will you just tell them to shut up whenever they say, "Hey, they lost, ha ha, they lost"? Will you just tell them to shut the heck up?
Well, I suppose I could do that. I don't know. I mean, people get pretty enthusiastic, right, when it comes to sports. So yeah. And
Uncle Bill just checked Black history. Our intro was in Kabul, back in the States now, but working nights.
Yeah, that's what I recall. Is that he or somebody was over way over in Afghanistan, and and yeah, now is working at an odd time, so not able to join us. But our instro, if you're watching later, nice to see you there. Make some comments. Let us know that everything is well. And like I said, come on in anytime you want, anytime. All right, well, cool. Let's do this one more time. I noticed that yesterday I never shared my screen once. Never shared it at all. So what's up with that? I don't know. So tonight let's share some screen. Let's get it off of me all the time. All right, so let's do it. Share the screen. I can hear my echo through your speakers there, Bobby.
What I'm going to do, I'm going to go ahead and reboot, because that's the last time I did it. I had to reboot and stuff, so I'll be right back.
Okay, sorry about that. But I'm going to continue sharing my screen. And I guess what I'd like to do is just go over to the Astronomy Picture of the Day archive. And they oftentimes have some pretty nice looking astronomical images. And yeah, I think I'd just like to go through some of those pictures and see what's going on there. Now, I haven't been paying close attention to the Hayabusa mission, but they have, arrived at this asteroid, right, Ryugu, and I think they've selected some possibilities for landing sites. They're going to actually be doing some kind of a sample return mission, right? They're going to scoop up some of that dirt and bring it back. So very, very cool. It's it's pretty interesting looking, of course. Let's see if there's no, that's the only view that we've got. There's nothing really zoomed in here. I could save this. And then we could look at it a little more carefully. Let's see, where am I going? I guess I want to come down here, and let's do that. Now this is just zooming in on this image, right? So the resolution isn't going to get any better, but we'll be able to kind of scooch ourselves in here and take a look at the dirt a little bit. Kind of interesting, right? Pretty cool. It looks it's, yeah, not really what one would what one would expect when thinking about an asteroid, right? It's pretty it's hard to tell, right? But this stuff looks pretty fluffy. I don't know if it is or not, but it looks pretty fluffy. And just a bunch of busted up rocks. Now I think the scale here, this is pretty big, right? I don't remember how many tens of kilometers, maybe hundreds of kilometers across it is, but these are big, right? These aren't just little rocks. We could probably find the scale on here somewhere. Let's see if we can do that. Hayabusa 2. So this is the official website of this thing. Let's get it into English. Thank you. And let's see. Well, here's the latest news as of the 5th of September. Let's sort of see. I'm going to have to translate this.
Okay.
Oh.
I'm Camille Duran. I know nothing about how to use a search bar. And Astronomy says, I don't even know what a Slack history is, much less how to search it. So you know is a lot more than most people know.
Yeah. 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 All right. Well, I'm going to keep going here. Let's see. We're at Hayabusa, September. Okay, so this is just all the news. So let's see. Thermography. Thermography. So that's obviously measuring some kind of temperature. Yeah, the thermal infrared imager, it says down here. So yeah, this is almost one rotation, it looks like. Does it say? So red indicates a high temperature, while blue indicates a low temperature. So kind of interesting, right? There's kind of blue and green on the bottom and red on the top. Huh. Kind of interesting that it'd be warmer on the top than it is on the bottom. It's really red up here. Look at that. So yeah, who knows what's going on there? Hard to know.
Okay, Uncle
Hard to
Bill
know
Duran.
exactly.
Slack is a lot like Discord, but more professional. The WSH crew has a work group there.
Yeah, cool. Nice. All right, let's keep going. We looked at Ryugu, and yeah, as I said, I haven't really kept up on that mission very much. As soon as they sort of got there, I was like, okay, well, this is going to take a while for them, to figure out where they wanted to land and all that. And I think it is, right? I mean, it's taking a while. They want to, not only go into, what would be a safe place for their little device, but they also want, to maximize the return, right? They want to try to find the best place that's also really, really safe. It's just like all landing missions, right? I mean, you want to put your spacecraft or your rover or your sample return thing somewhere where it's going to return, the most good kind of data, which hopefully, will turn into good science, good results, good understanding, right? All right, let's keep going here. So the NGC 6914 complex. My guess is that that's a cluster of galaxies of some sort. But yeah, let's take a look here, see what that is. Oh, it's not. Okay, it's a nebula. So instead of a big group of galaxies, this is just a big clump of gas and dust that's being lit up by some of these stars. I think you're sort of seeing two different things here, right? You're seeing emission, like you would, like a neon sign, right? This gas is glowing on its own, but you're also seeing reflection from the stars that are sort of inside of these nebulae, and that's lighting up the clouds, right? Lighting up the gas and dust, and there it is. So very pretty. A colorful skyscape. Yeah. So pretty good images of stars. These are called diffraction spikes, and those are caused by the actual optics of the telescope itself. And a lot of photographers actually like that effect, right? It sort of makes it look more spacey, right? Now, I look at those things and I see not ugly, but I see, diffraction spikes, and it's like, I don't want to necessarily see diffraction spikes, but I understand that there's an artistry in this too. And with the artistry, that does look really, really cool, right? But usually you want to keep those diffraction spikes to a minimum if you were to do any kind of science with this. But that's not what this picture is about, for sure. It's beautiful, though. And, again, it probably says, right? Let's see if it says how this was taken. Ivan Ender did it. It doesn't look, it doesn't look like there's a description of how the image was taken. But, probably, right? Probably it was taken with 3 or 4 different filters, and then colors were just applied to those filters, added up, mixed, either in Photoshop or one of the image editing programs, right? And so they sort of arbitrarily chose certain reds and certain blues and certain greens, and came out with something pretty nice. Pretty nice. Okay, so it looks like this particular object is somewhere in the constellation of Cygnus. Okay, yeah, which is definitely, part of the Milky Way, at least what we see from here. So that's pretty cool. Yeah, reddish hydrogen is the emission, so it's the red stuff that's glowing. And then the blue stuff is reflection. Pretty cool. Pretty cool. All right, let's take a look at it.
What telescope was captured with that?
It doesn't, it doesn't say anything about how this image was actually gotten. We could probably go to Ivan Ender's site, maybe get some more info. Let's just look really quick. I really like my guests here to sort of, give a little bit of direction in terms of where we go exploring the universe. So let's see. Diffuse nebulae. Okay, that's what this actually is. So, let's go back to this one. And can I select it? I can't select it. Let's do this. There it is. Let's see if there's any more info. It looks like there's going to be more info here. Okay, so he took this with a... I'm not quite sure what a 300, 1200 Newton is. Not quite sure what that is. But a very long exposure, right? 11.5 hours. Pretty amazing. Pretty amazing. Long exposure. Doesn't really say what filters were used, anything like that. Yeah, it's kind of ambiguous. Yeah, I'm not quite sure what these are. I don't know. Guess these were all taken with the same object, but yeah, I'm not really seeing, I don't know, I'm not seeing really any useful information here. So, nice images though, for sure. Pretty amazing. Again, these diffraction spikes. Oh, how do I move around? Here we go. Kind of cool though, right? We're sort of, it seems to me, right, that we're sort of looking through this nebulosity at these background stars. This to me looks like a person, right, from sort of the torso up, with their head and their outstretched arms here. Do you see that? It's got a little ball at the end there. Huh, kind of interesting. And then here's another person that's mostly buried in this, right? But he's sticking an arm up in the air. Pretty nice. That's a nice shot, of course. Astro-ender. Nice. Oh, look, he's got some list of equipment here, what he uses. Okay. So he's got a Newtonian telescope. That's because the focus, well, I know that because it's on the side of the telescope, right? So there's a primary mirror down here, and then there's a secondary mirror inside the tube here, which is a flat mirror that reflects that image to your eyepiece or your camera here. And that's why he's getting the diffraction spikes, because in order to hold up that secondary mirror, he's got some fins holding it up. So yeah, he's going to see diffraction spikes there for sure. But is this saying 3-inch? I don't know if it's saying 3-inch or not. That's kind of that's a little strange there, because that looks bigger than the 3-inch. So I don't know. Nice looking scopes. Cool. Let's look at some galaxies. Does he have any? Oh, he's got some nice. Oh, he's got quite a few galaxies. Wow. Pretty sweet. So here's the famous one, NGC 4565. It's a nice edge-on galaxy. It's a pretty good shot. Pretty good. Pretty easily visible in most telescopes. Probably need a maybe a 6-inch or an 8-inch to see this relatively well. And of course, right, I've got to remind you that it's not going to look like this in a telescope, right? This is a long exposure, so the conditions are different. But you can definitely see that it's extended, and you can definitely see this dark lane here for sure. But yeah, that's a beautiful galaxy. I like seeing pictures of it, and I like seeing it with my own eyes. That's over in like the Camelopardalis constellation, somewhere in that area, just north of Virgo. It's probably associated with the Virgo cluster. All right, so let's keep looking at these pictures of the day here.
Theodora says a typical mounting for the flat diagonal secondary mirror is usually called spider vanes. And yes, they do create diffraction effects.
Yep.
Okay.
Let's see. Well, aerosol Earth. Okay, these are just looking at the distribution of aerosols in the Earth's atmosphere. Planet-wide visualization produced in real time. So it's a combination of satellite and ground-based data. So black carbon particles in red. So over here in the western United States, yeah, we've had a lot of fires and all that. And look how it's sort of whipping around, right? I mean, it's going up and around, sort of concentrating in sort of the northern mid-Atlantic, right?
And, welcome, Adam Synergy from the United Kingdom.
Hey there, Adam. Nice to see you. It's early. It's very, very early or very, very late over there in the UK. So thanks for coming in, Adam. It's nice to see you. We're just looking at the astronomy pictures of the day here. I like to do that from time to time, just sort of look and see what's, what everybody's all excited about in terms of stuff. I wonder if these are like cyclones or something over here. Oh yeah, typhoons. Yeah.
I still love the newts though. Low cost per answer aperture.
Yeah. In terms of bang for your buck, a Newtonian focus telescope on a Dobsonian mount, that is the way to go. I mean, you can make your own. I mean, I made my own when I was 12. So, if a 12-year-old can do it, pretty much anybody can. So, yeah, very, very easy. And, yeah, I mean, you can get a lot of bang for your buck, right? You can have a large telescope, big telescope. I'm talking, without looking at the prices, my guess is that you could probably get a 14 or a 16-inch Dobsonian for around $1,000. So,
hey, Ray, why now from Southern Illinois? I think it was on Jill's channel yesterday as well, if I recall correctly.
Yeah, I think I remember seeing Ray there too. Hey there, Ray. Nice to have you coming in. So we're just looking at the astronomy pictures of the day here, just going through a few of them. This is just a really, really fun, casual get-together of people who share a common passion for the science of astronomy. So sometimes we go a little bit light, just look at some pictures and make some commentary about them, notice things. Sometimes we go a little bit deep. We go into papers, research papers, all of that. But I think today's live stream is going to be pretty casual, I think. So let's look at a powerful solar flare. Okay, it's a little movie. Yeah, so this is using probably the Soho LASCO device, and what it does, it's a coronagraph. It's just this little thing that blocks the light of the sun. So some of the telescopes on Soho, which is a spacecraft that is actually making observations of the sun, can look at the sun in sort of a special way, right? Instead of being blasted by that bright star, right? They put a little mask over it, right? And so what you can do with that is you can see everything around it, including the background stars, right? They sort of goose the gain up a little bit, so you can actually see, third or fourth magnitude stars here, and you have no problem with direct sunlight blasting in. But if there's any activity around the sun, like the corona, right, or if you have any kinds of activities on the sun that eject material, you're going to see it here. And this looks like a pretty dramatic event here. So I don't know, when did this happen? Yeah, I'm not quite sure. Okay, is this an actual recording of that huge event? I guess so. Okay. So this is 10 seconds, which lasted, well, it's a 10-second video apparently, but the whole event lasted over 4 hours. All right, so just keep that in mind. Things don't happen that fast. But let's take a look at that. It's really short. Boom. Wow. Yeah, that's pretty intense. See all that, see at the end how there was all those particles and whatnot. just blasting the camera. Look at that. Boom. Yeah, pretty cool. Pretty cool. Happens all the time. So there's some aurora around Saturn's North Pole. Is it the North Pole that has the hexagon, or is that the South Pole? I think it's the North Pole, isn't it? So these aurora are usually seen in the ultraviolet, not necessarily seen in the visible bands. But
okay,
of
right
course,
now I've been doing amateur astronomy since I was 8. He was 8. I'm 50. He's 51 now. I currently have a 10H Sumo DLB, a small refractor, and a pair of binoculars. Also, a nice big dark sky. I live out of the country.
sweet.
Adam Synergy said NASA JPL will have won an Emmy for coverage of the Cassini mission finale.
Yeah. Adam, I saw that, and yeah, I just sort of saw like a tweet about that, and it's like, oh, that's kind of interesting. I need to look into that a little bit more. So yeah, I did hear about that, but yeah.
Speaking of Emmys, I think this is way much better than that Miss American pageant as well.
Well, I think that's a matter of choice too, right? So, so nice, Ray. You've got a 10-inch Dob, refractor, pair of binoculars, and a dark sky. Well, you are set. So yeah. Hopefully you're able to get out. Do you just like observe with your eyes, or do you take photographs? Do you actually do any kind of science? Where are you in terms of that? Oh yeah, and there is a SpaceX launch. I guess at least according to the chat here at 4 hours UTC. So yeah, that's only like an hour and a half from now. So and that's why Adam is up, because he wants to see the Falcon 9 rocket launch. Cool. Yeah, it's going to be, well, that's definitely going to be a nighttime launch. So those are always pretty spectacular on their own. And, but boy, these are getting pretty routine, right? It's almost, I'm sort of waiting, and I don't think that we're there yet, right? But there's going to be a point, right, where it's like rocket launches are, potentially going to be like, aircraft. And it's like, when do we stop watching rocket launches? And I got to say, that so far, every rocket launch that I have seen is absolutely spectacular. So I don't know if I will ever get tired of it, but definitely, right? I mean, if there's a rocket launch every hour, it's like I'm definitely not going to be able to watch every single one of them. But as long as they have cameras on them, yeah, somebody will be watching. Ooh, 60%, huh? Ooh. They have some clouds over there or something. I know there's a hurricane out in the Atlantic, but I think that's pretty far out still. So I'm wondering if they're just having some tropical stuff. And that kind of weather does tend to be a little bit more calm at night. So but the forecasters know their thing. So Kennedy is under a lightning advisory right now. Oh, okay, it's Vandenberg. Okay. That's cool. Now, wait a minute. Is it Vandenberg or is it is it Kennedy? I don't know. Uncle Bill is saying Cape Canaveral and Adam is saying Vandenberg. Huh. Well, we will get this resolved. The tension is high at Astronomy Daily Live. We do not know where this rocket is launching from. Okay,
I
good.
think I'm on the Space Videos YouTube channel now.
Yeah.
And I think they're doing like past launches, like a replay of past launches right now.
Cool.
So I can just go ahead and just turn it off and stuff.
All right, well, I guess that's kind of an interesting picture. Lava and the moon. The bubbling, boiling moon. Kind of interesting. 3682. A sideways spiral galaxy. What does that mean? Oh, okay. So
Right
yeah.
now, I like to do some solar work with a solar filter, but mostly I just like to go out and observe deep sky galaxies and hit some favorite targets. I don't itch because I don't have a motor mount.
Gotcha. Yeah, Ray, I observed with my 10-inch Dobsonian f5.6 from age 12 to age 47. So for, what was that? What is that? 25 years? 35 years? I don't know. I did exactly what you're doing now, and that is brought the scope out, looked at stuff, looked at a lot of stuff, right? Looked at a lot of stuff. But gotten into this, gotten into the science a little bit more with my current scope because it can track relatively well. But yeah, I'm going to have to work on my system too in terms of tracking a little bit. But yeah, cool.
How is Thor not going to be launching? Is that like an amateur radio satellite? I don't know what it is.
The one that we were talking about the other night?
No, the Telestar 18B, is that going to be an amateur radio satellite, or what's it going to be?
Oh, yeah, I'm not exactly sure, but it's probably a communications satellite of some sort. Yeah, not exactly sure what it is, but yeah, I mean, most likely with that kind of name, it's going to be some kind of communications satellite. Yeah, they may have other payloads too, right? They might. Well, that's a pretty sweet looking galaxy. Kind of interesting. It's edge on, right? Edge on, but not your typical spiral galaxy, right? I mean, we just looked at NGC 4565, right, which is sort of your prototypical spiral galaxy, right? It's got a bulge in the middle, and then a dust lane, and even seeing it on edge, it's like, yeah, there's probably spiral arms there, right? But this guy, something's different, right? It doesn't have that disc shape, right, with the bulge in the middle and sort of tapering out to the sides. It's something else is going on here. Something else for sure. Kind of cool looking though. Lots of nice detail. I'd like to. So I guess this. Wow. So this is okay. They call this the hamburger galaxy. Pretty funny. Oh, okay. All right. This galaxy is actually part of what is called the Leo triplet. This galaxy is right next to Messier 65 and 66, and I'll bet you we can get a picture of the Leo triplet. There we go. Okay. So I forget which one is which, Um, okay, so M66 is bottom right. So this is 66, this is 65, and this is what we were just looking at, NGC 3628. So yeah, these are really, really nice to see in a telescope. These are pretty bright. This one's much fainter, right? Again, you know, these are long exposures, so we're able to see, you know, quite a bit more of it here. But usually what you'll just see looking through a telescope with your own eyes is you're just going to see this central bright area, right? And that goes for all of these, right? You're really not going to see any of this outlying stuff. But okay, cool. So that's just a really, really nice sort of zoomed in view of that. There's great structure here. Look at that.
Great. I'd like to thank Uncle Bill for providing me a link about that satellite they're going to launch at midnight at Eastern Time.
Cool. Yeah. So a Telestar, is it just your communications satellite? I don't know. Yep. Double cluster is fantastic. Fantastic. You just need a pretty wide field of view, you know, to really grab both of those at the same time. So, you know, it's a great binocular object. Or, you know, if you have a pretty fast telescope, then you can have a pretty wide field of view and get both of those. I know with my telescope, right, I've got an 8-inch Schmidt-Cassegrain with a 25 millimeter eyepiece. I can just barely get both of the cluster members in there. Yeah, it's pretty stupendous, pretty awesome shot. And you see, yeah, there's still some diffraction patterns here, but that's sort of been, you know, de-emphasized, right? Because we're not really seeing it a lot in the other stars. But look at the colors of the stars; they're fantastic too. It looks like there's a galaxy maybe behind this. It looks like a different galaxy. Pretty cool. All right, let's keep moving here. Veil Nebula. Let's see, the North Polar Hexagon. Okay, that's just the regular view that I think a lot of us have already seen. If you don't already know, there's this interesting structure on Saturn's North Pole, and it's a hexagon. And they've been trying to understand this, but I'm sure that they're pretty sure that they understand it, but I don't know if they do or not. I think it's just kind of neat. Let's see, real-time Perseid. I don't know. Okay. Oh, there we go. That's pretty sweet. Yeah, that's a nice little. Kind of interesting. There's something over here too in parallel. You see that right there? What is that? I don't know. You can see the twinkling stars. Here's Vega, and here's Lyra over here. So that means that Deneb has to be up here. Altair's got to be over here. Pretty cool. Crab Nebula from Hubble. Well, that always looks nice. Without any atmosphere, it's you know, a little bit easier. Oh, come on. It's trying to load. It's trying.
Now, Uncle Bill, I think it would be like, I'm not sure, but can you capture C bands and KU band on SDR? I don't know.
Yeah, I'm not sure about that either. I never remember what the frequencies are. I know that there's somewhere around like 145 megahertz. I don't remember what band that is, though. But I think that's a ham band, isn't it? Pretty nice picture. HST, so, you know, what do you expect? Cool. All right. Well, I think probably what we should do is at least start a constellation of the day, and it'll probably run a little bit over, so maybe we can sort of bleed it into tomorrow and the next day. Because yeah, I like to. I've sort of decided that I like to spend a little bit more time on these constellations and these objects. Give them the time that they sort of deserve, um, and not try to necessarily rush through them in any way. That's one of the you know cool things about a live stream, a daily live stream, is that we can do things at sometimes a little slower pace, and dive into these things a little bit. So cheers.
Alright, can anybody hear the TV? If so, I'll turn it off until the live stream. Because I do want to watch up lunch as well.
I can't hear a thing.
Alright.
So let's do a constellation of the day. So let me get my screen set up here. That I will go over here. So there are 88. Oh, I meant to go share my screen. So there are 88 constellations in the entire sky. And I have an alphabetical list of them all here. Right? Here they all are. And there's 88 of them, right? There's 88 right there. So let's go over to random.org. Random.org. And have random.org choose a number between 1 and 88, and then we will start looking, at least start today, looking at that constellation in some detail. Just sort of, looking at some of the stars in it. Sometimes the stars are pretty interesting in and being themselves, right? They're like a binary star or a variable star or some kind of star, right? And then we can look at any of the non-stellar objects, right? Any galaxies or clusters or nebulae or anything like that in there. And then, just sort of do sort of a full coverage of this constellation, regardless of where it is. I mean, I think for the most part here, we're mostly northern sky biased, but I like to learn about the southern sky, even though I'll probably never see it. So here we go. Ready? Bam! Number 11. So let's go over to number 11. Camelopardalis. Yes. One of the constellations that's impossible to pronounce. So this is a weird constellation in that it's this animal that's like half camel and half leopard, I think, or is it just a giraffe? Oh, I don't remember now. Let's go find out. So we're going to go over to Google here. You know, I just got to say that it's really, really nice to be able to type with two hands and not have to hold on to this mic. So have I mentioned that? It's pretty nice having two free hands. Should have gotten this mic stand long ago. So Camelopardalis. Camelopardalis. Or Camelo. Who knows? Camelopardalis. I don't know. So okay, it's supposed to be a giraffe. I thought that this was. I thought that some cultures have it being a camel and a leopard. I don't remember now. So very much a northern constellation, as you can see. Here's the North Pole. Here's the North Star, right? Now, not exactly on the North Pole, right? It just so happens that during this time, right, that we're alive, this bright star is right next to the North Pole. But that hasn't always been the case, and it won't be in the future. Anyway, so here's Camelopardalis, and as you can see, pretty big constellation, right? So we're going, kind of hard to see here. Here's 5 hours, here's 4 hours, here's 3 hours, right ascension. So here's 3.5. It goes from 3.5 all the way around to 8, 9, 10, 11, 12, 13, 14. Wow, so it covers about 10 hours right ascension. But in the sky, right, it's a little bit smaller than that, right? Hey, Bobby, I'm getting a little...
Yellow, y'all.
Hey there, Uncle Bill. So, Bobby,
I'm... your bandwidth issues fixed.
Yeah, very cool. Bobby, I can hear me through your
that might have been me.
System again. No, I think it's Bobby.
I turned it off just in case.
Okay, appreciate that. So yeah, Camelopardalis is pretty big. I can still hear me somewhere. I can hear an echo. Yeah. Let me try quickly. I'm going to go ahead and I'm going to mute you, Bobby, and see if it goes away. Yes, it does. It does. So I'm pointing the finger at you. All right, I'm going to keep going here. So pretty big constellation, but pretty faint stars, right? Nothing really exciting or at least amazing about the stars. And as these things usually go.
Cosmic, I'm going to have to switch to a different operating system because right now I think if you're still getting that echo.
Yeah, I am.
I want to restart.
Okay. The neck of a camel and the spots of a leopard. Thank you, Adam. I knew that there were camels and leopards involved there. I just didn't exactly remember what the combination was. So cool. Yeah. Well, you know, most of the constellations, right, sort of don't make sense. You have to, you know, be pretty free with your interpretations of things. You know, these people didn't have anything else to do, so they let their imaginations run wild. All right, Atta, very, very good. Thanks for coming in. You are fantastic. Glad you could come in anytime. And yes, if it's clear, okay, don't sit here and watch this, right? I want you outside looking. Yeah. All right, so let's keep looking at this constellation for a little while at least. So as with most constellations, the brightest star is usually called Alpha, and the next one is Beta, and then it goes from there. Not a lot of bright stars in this constellation, it looks like. So the other thing that I like to do before I go into sort of, you know, the modern explanations of all these things is I like to go to my Burnham's Celestial Handbook and take a look at what Mr. Burnham said about this constellation and the stars and objects in this constellation. So here I have my stack of 3
While you're looking that up,
right down here on the floor.
I'm sharing my stellarium. It looks
Okay.
like a giraffe in stellarium.
Yeah, I think that's what it's supposed to be, is a giraffe, maybe with, you know, like a leopard print, but I think giraffes sort of have a leopard print anyway. All right, cool. And I think Camelopardalis is 1. It's in volume 1, and I've had these Burnhams for over 30 years. Okay, so they're a little beat up, right? They're a little beat up. This one, the cover just actually recently came off. I think I tried to tape it once, and that has now failed. Yeah, there's like tape and all kinds of stuff here, so I definitely need to fix that. So these books are in pretty sad shape. This was the last one to actually have its both front and back covers, right? It still has its back cover. It still has its back cover, but now, yeah, unless I put that back on, it won't have its front cover. So Burnham's is organized according to constellation, which is very, very cool. Alphabetical order. So I'm just going to look up Camelopardalis. Bobby is back with us. Hey.
Hey, just switch back to Chrome. I'm on Chrome OS mode right now.
Okay, cool. I can still hear the echo, though. So Burnham's does this really, really great thing where they list like all the known binary stars, and then all the known variable stars, and then all the known non-stellar objects, right? Like galaxies, nebulae, all of that. So, if you're into observing binary stars, right? Camelopardalis has a few, right? Here's one page, or 2 pages, I guess, and it actually goes over. Yeah, it goes 4 pages. So these are all binary stars. And so that's all the binary stars. Then it goes into variable stars. There's all the variable stars here. A couple. So if you're into variable star observing, quite a few there too. And then it lists all the non-stellar objects. So mostly galaxies, and then a short list there. So yeah, quite a few. So they first start talking about S. Camelopardalis being a variable star, long period pulsating variable star, discovered in 1891. It's got an average period of 326 days, and it's the change in brightness sometimes reaches 3 magnitudes. So pretty cool. Brightest it gets though is about 8. So you're not going to be able to see this naked eye. This thing is not focusing. There we go.
Looking good.
Yay. So yeah, they sometimes provide little finder charts so you can actually find it in the sky, right? They've got it marked there. And the other thing that they do, right, is they list the magnitudes of some of the nearby stars. And sorry that that's blurry, but this thing doesn't want to focus. Of course not. Of course not. So that's pretty cool. Let's see what else. Okay, here's a light curve, and some pictures showing it when it's faint and bright and faint again. So there's the light curve here, and kind of hard to see. And now, oh, there it focused. So you can see, a pretty long period, but the brightness isn't always the same, right? I mean, sometimes it was really bright, and sometimes it was a little bit fainter. And here's some pictures of it during its different phases. That's kind of cool. Blurry again. Yeah. Show you my ugly hand. Okay, then they go on to Z Camelopardalis, which is also a variable star, and it's a little funny when it comes to variability, right? It's just sort of all over the place, although there's a little bit of periodicity there, right? A little bit, maybe on the order of I don't know, 25 days, something like that, right? There's a peak and a peak and a peak and a peak, and those are pretty equally spaced out, but a lot of variability there, though, right? And something really weird happened there, right? It didn't change at all. So, let's so that's Z Camelopardalis. Let's dive into that a little bit. See if Sinbad has anything interesting about Z Camelopardalis. So Sinbad. Basic search. I'm gonna go Z Camelopardalis. Dwarf nova, they're calling it. Hide that. Been studied pretty extensively. Distance, let's see, they have a distance on this guy. 225 parsecs, it says. They're using parallax. Relatively recent measurement too. That I'm not quite sure if that's Gaia. Probably not, but we could actually look at the Gaia parallax of this guy too and see. But yeah, they're getting a distance of like 225 parsecs, which, oh, you know what? I do not, and this is a first, right? This is a first. I do not have my calculator within arm's reach, but I have an excuse. I have an excuse. See, the job of cats is to knock things on the floor, right? If they're up on something, they have to be down on the floor. And it was decided today that my calculator be placed on the floor. So let me go grab that really quick. It's just around the corner here, but it's not within arm's reach, which is, oh, I'm hanging my head in shame. So hold on one sec. Okay, I've got it. I've turned it on. It still works, even though it has fallen 3 feet off of my desk onto the hard floor. Anyway, so 225 parsecs. And 1 parsec is about 3.26 light years. So we're talking 733 light years away. So, you know, that's actually pretty far. That's pretty far. But that explains, you know, why it's so faint, right? I mean, it's 11th, 12th magnitude, something like that. 10th, 11th, 12th. So yeah, pretty faint, but pretty far away, right? So pretty cool. Let's see. Is there anything? If there's going to be anything interesting here. I don't know what data this is. Oh, okay. Well, let's just see. This might just be a spectrum. Might just be a spectrum. We'll see. Oh, it's trying to grab a FITS image. That's not going to work. All right, forget that. So Z Camelopardalis. Let's see if there's any interesting papers specifically about Z Camelopardalis. There's BZ Camelopardalis. That's not the same thing. So the WISE light curves of Z Camelopardalis during outburst. So WISE is a spacecraft. I don't remember exactly what WISE is. We can look that up really quick. WISE craft. Wide field infrared survey explorer. Of course, it's a spacecraft. Cool. Okay. Yeah, and it's definitely looking in the infrared, right? Even the thermal infrared here at these longer wavelengths. So cool. And I think it's okay. So it was reactivated in 2013, and I guess it's been going ever
I'm
since.
here, Madam Sunji.
What was that? I missed. Oh yeah. Yeah, Bobby's.
To know where your geographical location is, Bobby.
Yeah. Where are you on this planet, Bobby?
I'm at Louisiana.
Louisiana. All right, so that's WISE. Let's look at those light curves. Let's sort of see during an outburst. Okay. The cool thing about most of these papers is that they sort of, you know, during their introduction, they sort of usually present sort of a history of what's going on with this object. So we might be able to see that here as long as we can get in. Ah, yeah. So the WISE mission happened to observe the cataclysmic variable Z Camelopardalis at the peak of an outburst. So the WISE single exposure data shows that ZCam was highly variable at 12 microns, but only marginally so at shorter wavelengths. So that's kind of interesting, right? Usually when you look at objects with different wavelengths, what you're looking at is sort of just different material, right? Different atoms, different molecules emit or reflect or transmit light at different wavelengths. So when you look at an object at different wavelengths, you're usually looking at just different stuff. But the fact that they were seeing a lot of variability at one wavelength and not so much anywhere else, that's a little curious. ZCam is the synchrotron source, they say. Okay. So ZCam is the prototype of a small subgroup of cataclysmic variables that show standstills in their light curves. Yeah, okay. And we saw that on the Burnham's plot. It's like, variability, and then nothing for like 100 days, and then it variables again. So interesting. So yeah, they're trying to understand that, right? So synchrotron emission, that's pretty cool. We'll have to get into the different kinds of ways that light can be generated. Synchrotron emission is just one of the many, many ways that light can actually be emitted from things. Synchrotron is pretty high energy, usually, I think. You're taken, it was the third brightest dwarf nova. Okay, so yeah, so the observations that they made were just at the peak of a normal outburst. Pretty cool, though. I wonder if we have access to WISE data from the WISE spacecraft. I don't. Is that a European? No, that's a spacecraft. Mission goals. Trying to see because if it's American, then I, at least being an American, should have access to it. So yeah, we'll have to find out if we can get some data access to the WISE mission.
Wikipedia says it's a NASA spacecraft.
Is it NASA? Okay. Well, I'm wondering if WISE data is available somewhere. Yeah, we can explore that a little bit.
You might find it under NEO-WISE.
Okay. Yeah, that's...
It was reactivated in September 2013 as NEO-WISE.
NEO-WISE, cool. Okay. We will definitely do that. So I guess here's some light curves. So the top three panels present the WISE light curves of ZCam. Okay, well, cool. So yeah, kind of interesting that they're seeing variability here, right? These are the same times, right? This is some kind of Julian date. So not seeing a lot of variability here, right? Sort of similar, right? When this goes down, this goes down. When this goes up, this goes up. Yeah, so these look about the same, but look how different this one looks, right? At just a different wavelength. So, yeah, kind of interesting. I wonder what's going on there. Hard to know. Hard to know. They may actually have an explanation in this. I'm not going to get into that. I'm just looking at pictures tonight. So yeah, I guess their explanation is synchrotron emission is causing that. Huh. Interesting. Okay. Well, so that's just one paper of many about this guy. Let's see. Can we go back here? Wrong one. What else we got here? The interruption timescale of classical novae from the expansion of the Z Camelopardalis shell. Okay, interesting. So it's actually got a detectable shell of material that I guess is probably expanding outward. Huh. X-ray observations. That's cool. There's a German paper, which I unfortunately cannot read. Does anybody know German? Do you know what that says? That says false. Not quite sure what the rest of it is. Let's keep going here. The ancient nova shell around the dwarf nova Z Camelopardalis. Oh, in Nature. Let's see if there's pictures. And I think we're running a little bit long too, so I'll start wrapping this up. Let's just see if we can. Oh, I don't think there's going to be anything here. That's too bad. Let's just do a quick look this way. What am I going for? I'm going for archive. Just do a quick title search here. Don't think it'll come up. Nope. All right. Well, we're not going to be we're not going to be able to gain quick access to this. So cataclysmic variables are binary star systems in which a red dwarf transfers hydrogen-like matter by way of an accretion disk to its white dwarf companion. So I guess that's what they're thinking that Z-Cam is. Yeah, I'd like to see a picture of that. I wonder. If Hubble ever looked. Let's just see here. Camelopardalis. Well, maybe that's the right region of the sky. I'm not seeing much there. Can't say as I see much. Not quite sure what these guys were doing. We can look really quick. In a search for interesting objects. I like it. Now, what do you think about that? Getting HST time because they want to look for interesting objects? Wow. Well, they got 80. Well, I don't. I don't know. I don't know. I mean, there's some papers that are related to the proposal. So Don't know if it's a waste of time, but they got exactly 80 seconds of HST time, right? So they didn't get a heck of a lot of time, and I'm not quite sure what they were looking at there. Let's look at the other one. Yeah, I'm not seeing much of a difference there at all. Is it like, no, it's the same wavelength, everything. So yeah, there must be something of interest here for them, but I don't know. Maybe not. Maybe not. All right, you guys. Well, we're going to continue looking at Camelopardalis probably tomorrow. So, so for now, I'm going to stop sharing and get back over here and let all you good folks go for now at least. But we'll definitely be back tomorrow. Don't see any reason why we shouldn't, because astronomy is fun, right? It's fun to talk astronomical things, think astronomical things, and this day and age, right, having access to all this information right at our fingertips, right? Don't even have to move, right? We can have people coming in from all over the world, sharing a common space, and thinking and looking at astronomical stuff. So very, very cool. All right, well, I'm going to get out of here for now. I will see you all in a little less than 23 hours. I think 22 hours and 33 minutes, at least by my clock or so. So that's a little less than one spin around. All right, I think I'm going to get out of here. If you haven't subscribed yet, make sure to do that. Thumbs up. That's always nice. And spread the word. Spread the word. You know, I think there's a large community of folks like-minded who, you know, enjoy this form of live stream, where it isn't necessarily an interview. It isn't necessarily having an expert sort of telling you, you know, what to think and what we know and all of that. I'm just sort of here as a host, thinking out loud and just having a great time exploring and thinking about, you know, the universe. And I've been doing this forever, and I see no reason to stop at all. I've been live streaming now for, I started in January, so it's been like almost 9 months now. So pretty good. Definitely not up to the level of many others who have been doing this for years, over 10 years in some cases. So you know, hats off to all of those. You know, Tony Darnell, Deep Astronomy, check him out. Check out Pamela Gay with CosmoQuest, Fraser Kane, Paul Sutter. I'm trying to think of a few other ones. Skylius, of course, over on Twitch. All awesome, you know, dealing with the science of astronomy in different ways. And yeah, I think it's very, very cool. I am definitely still trying to find my groove. And my goal here is to just try to get better every single day. And this is good practice. So, all right, I'm going to get out of here for now. So take care, everybody. I will see you on the spin.
Late breaking news. The rocket launch just got pushed back another 30 minutes.
Okay. All right. So, but they're still going to try to launch today.
It looks like they're still shooting for today. Well, it'll be in the morning.
Right.
4:30 Universal Time.
Okay. All right. Well.
4:30 Eastern.
Yeah. Yeah. It looks like maybe they're having, you know, some weather problems or something like that. So, yeah. Well, hopefully, you know, it sounds like they have sort of a large window, which is nice, right? I mean, it's nice to have a nice wide window of opportunity. But you know, if they have to scrub, they have to scrub. That's how it goes. Do you want your you know device delivered to space, or do you want it to just sort of explode? So you know, it's your choice. All right, you guys.
That's true.
Yep. All right. I'm gonna get out of here, you guys. I will talk to you in 22 hours and 30 minutes. All right. Bye.